Okay, electrostatics. We did this in grade 10 and in grade 11 and not really in grade 12. But they don't have a definition here, but they do have draw the electric field pattern, and that is basically a definition. It's theory work, kind of. It's the same, it's also level 1. And what I'd like us to remember is WWPCD. It's what would a positive charge do. Electric field is what would a positive charge do. So a positive charge would move away from a positive charge, which is why the arrows are moving outwards. And if you just want to see here, I don't know what they're saying here in the corner. They're saying more than one, if you draw more than one charge, you'll get 0 out of 2. So they just wanted the electric field pattern around this one. They don't want you to draw the other one. So if you draw both of them, you'll get 0 out of 2. You must just do what the question says. Don't try and make extra stuff for yourself. Just, if it says draw it for the 4, just draw it for the 4. Don't do extra. Then for 741.2, another thing that we need to be very, very careful of. Field, there's 2 words. There's 2 F words in electrostatics. There's field and force. Alphabetically, field comes first. Alphabetically, field is E. Force is F. If you mess that up, you're going to get 0. Electric field, you have a charge. They gave you a charge, and you have a distance between their centers. And X isn't even a charge, because electric field, I don't know if this is going to work, but electric field is kind of like sex appeal. You can feel it whether or not you're in a relationship, kind of. But force is like a relationship. You need 2 charges for a force, but you can have sex appeal on your own. The field is the sex appeal, the relationship is the force. So electric field, if there was a charge over here, it would feel a force. There isn't at the moment, but you can still work out the electric field at this point. You only need 1 charge for that. And again, even if you don't have a calculator, formula, substitution, answer. You can get 2 out of 3 for just putting the numbers in the place. And K is a constant. You'll find it on the formula sheet. So I do think we should all be able to do that. Also, if you are still here and paying attention and things, typically they will ask you something about F and something about E. Not generally in the same question, but we can kind of maybe think now we've done the E bit, so now we probably are going to do an F bit at some point. Oh sure, but here comes your definition. Okay, so the definition part, state Coulomb's law in words. So Coulomb's law, we should be able to do, only because it's the same as Newton's law of gravitation, pretty much. So we should be able to do that. I'm not saying we can, but that's a nice, easy definition. Well, maybe not easy, it's quite a lot of words. But basically, you're describing Coulomb's calculation formula thingy, doodad, in words. So the electrostatic force is directly proportional to the product of the charges, and inversely proportional to the square of the distance between their centers. So this question doesn't say their centers, which is a bit unfortunate, but it should be their centers, but they didn't have to because they said point charges. So if you say point charge, you don't have to say their centers, but when you do the gravitational law, you have to do their centers, which is why I'd prefer we just always say their centers. And you can see here, if you mention mass, you get 0 out of 2. So they say point charges, which means they don't need to say their centers, but I would rather we focus on saying their centers because the gravitational law needs you to say it. So just always say it. But this one is charges, the other one is masses. So if you make a mistake with that, you're going to get 0, which is going to be a bit of a waste. Okay, what's happening now again? Oh, goodness, Terry. Okay, so now for 7.2.2, see here, now they're going to ask us for force, because they already asked us for electrostatic field. So typically they ask you one of each. So now this story here, they give a whole story about the balls, they're hanging. Then if we can just check the numbers. So once again, 10 centimeters apart, I can see that on the diagram. 9 degrees, I can see that on the diagram. And this is a totally different situation. It doesn't link back to the previous one, but they did tell us that the mass of each ball is 0.012 kilograms. So that is a number that is not given on the question, which is why we need to find the numbers in the questions and label them. What we do with this number is we work out the weight. So the weight is equal to the mass times the gravity. And if we want to try and work out the triangle, so I did it with my grade 11s, I'm not sure if I did it with you guys, but how you do it is, so let me just show you quickly, I want to see if I can get this right. This force is going that way, towards the ceiling. The weight is going down towards the earth, always, and the electrostatic force is going this way, because they're repelling each other. Now, I'm not sure if I'm going to be able to move these arrows separately. No, I can't. But basically, what you do with the red, the blue, and the green, one of them you elongate. So, for example, I'm going to elongate the red one. I'm going to keep the green one still. So, you elongate one, or lengthen one, or whatever word you want to use. You keep one still, and you shift one. So, you keep one of them still, you elongate one, and you shift one. And then it should work that you can get a closed triangle of forces. So, sorry, I just want to start that again because it doesn't look like that one's actually going to work. But if you elongate one, shift one, and keep one still, it should always be able to work. So maybe I'll elongate the blue one rather. So if I elongate the blue one, and then if I shift the red one, and then this green one can just stay there. Just move him a little bit. Shift one, elongate one. Oh, anyway, you just want to make a closed triangle. So here's a closed triangle. The red is the W. The green is the electrostatic force. And the blue is the tension. And then the 9-degree angle is between the weight and the tension. So in my diagram, it would be there. But if you can't make this triangle, you're going to be in trouble a bit. But anyway, so they are asking you to work out the charge. So I would rather just work out W equals mg and do 0.12 times 9.8 and get a number for that. So that means I have the red side. And if I'm trying to get the green side and I have the red side and this angle is 9 degrees, you can actually use the sine rule. You can do sine of 81 and sine of 9 if you want to. Otherwise, you can just use normal trig. And the sine f over sine of 9 is equal to w over sine of 81. So that's the 0.012 times 9.8 over sine of 81 is equal to f over sine 9. And you're going to end up with f being whatever they got, 0.0186. It'll be the same thing. You're doing the same thing. Then you will use the force formula. You will sub in the force that you got. You'll sub in the constant. You'll sub in the distance between them, which is 10 centimeters. That's 10 centimeters divided by 1,000. Divided by 100, because you need it in meters. Centimeters, century is 100 years. So centimeters, you need to divide by 100 to make it into meters. And then you can work out the charge of QB. So what they did there, what did they do? Oh, sorry. So they want the initial charge. Oh, sorry. Okay, so ball B touched ball A at some point and shared its charge with them. So two identical neutral balls. So in the beginning, A was neutral and B was also neutral, just hanging there. Then in the story, they gave B a negative charge, they attracted to each other, and then after touching, they're repelled. So basically, the answer that you get for the charge, this is a nice little question as well. The answer that you get for the charge needs to be doubled, because at this point in the red, each of these spheres has that same charge. But in the beginning, A had a 0 charge, A had no charge, and B had this charge times 2. And then when this happened, A and B shared the electrons equally, so they each got the same charge. So that's why this doubling thing is happening at the end, because they are asking for the initial charge that was given to ball B. So ball B was given an initial charge, and then it shared its charge with neutral A to end up with the final charge, which is the one that you calculated here.